because I was very quiet the last couple recordings. Okay, so I pulled a definition from the good old internet. Okay. It says the distributive property lets you multiply a sum. So you have a sum, x plus 2, 3x plus 6, 3x squared plus 2x plus 6, by multiplying each addend separately. So x is an addend, 2 is an addend. So you take 5 times x and 2 times x, and then you add them, right? You add those products. Does that make sense for our definition of distribution? You're taking each of the things in parentheses that you're adding together or subtracting. You're finding those products, and then you're doing the operation. So in the bottom one, we have a trinomial. We have a quadratic trinomial of degree 2, and we're taking 5 times 3x squared, finding that product. We're adding 5 times 2x, finding that product, and 5 times 6, finding that product, and then adding them all together. Again, why is that important? Well, because when we look at two binomials, because we've just been looking at singular things, a 5 or a 5x, right? When we take two binomials, what we're going to be doing essentially is the distributive property. And a lot of teachers, unfortunately, too, they talk about FOIL, which FOIL is a good way to remember what to do, but they drill that into us so hard that whenever we think about binomials and multiplying binomials, we forget that what we're actually doing is distributing, okay? And you just think FOIL, 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 FOIL without really understanding what that means. So before I teach you that, before I teach you FOIL, those little shortcuts to help you remember the rules, you have to remember that FOIL is a shortcut. FOIL is a way to help you remember how to multiply, but that does not tell you what you're actually doing. And what you're actually doing is the distributive property. Okay, so let's move on here. We actually have another Bell-work problem. It's pretty short, but I just want to remind us here how to deal with a negative. So when I have a negative in front of my grouping that is in parentheses here, what do I do with that negative? I distribute it, which means I multiply, I find each of the products of those addends, right? 3x squared times negative 1, 2x times negative 1, 3 times negative 1, and then I rewrite it. So that's what I'm going to do. I'm going to distribute that negative, which now I know what that really is telling me. So that's negative 3x squared minus 2x minus 3. And again, we saw that that was very important when we were subtracting polynomials. For example, if you had x to the third minus 5x minus 2, and then you were subtracting, and we put parentheses, 4x cubed plus 6x plus 4, then you would be applying that same distributive property and turning that into an addition sign. Do you have any questions about the basics of distributive property before we see how it's applied to binomials? No? Okay. Here we go. We're starting a new section. This is 7.2. We're doing notes today. There's going to be a lot of them, but I will give you breaks, and then we will not have homework other than to re-watch this video that I'm recording right now. Yeah. Okay, so multiplying polynomials, one of the most crucial sections in Algebra 1 and Algebra 2. How can you multiply two polynomials? We talked about this last time. I don't know if you remember. The product of two polynomials is a polynomial. Therefore, polynomials are blank under multiplication. What do you think that word is? Starts with a C. Closed. Yep. They're closed. Meaning, of course, that no matter what two polynomials I take, If I multiply them, if I find their product, I will get a polynomial. So those polynomials, all polynomials, are closed under multiplication. We just talked about this in the bell work. So you can use the blank property to multiply two binomials. Distributive. Again, I cannot emphasize that enough because I don't know who you're going to have for Algebra 2. I don't know what your experience is going to be, and I know from what I've heard and what I've seen, a lot of teachers, they say, oh, just FOIL, or just reverse FOIL, or just FOIL, 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 and then you forget that it's distributive property, and that's what we're doing. Okay, just like PEMDAS is an acronym to help us remember order of operations, PEMDAS isn't order of operations, it's a way to remember order of operations. Okay, so we're going to start with the distributive property first before I introduce that shortcut called FOIL. So go ahead and write those down, leave some space, because you're going to need it. So what we're going to do is we're going to think about two things separately. Before, what would happen if I just said you had x times the grouping x plus 5? What would you do? You would distribute the x, right? The same thing with 2. If I had 2 times x plus 5, you would do what? Yeah, so what we're doing is just two separate distributions, and we're adding them. Does that make sense? We're taking x squared plus 5x plus 2x plus 10. Does that make sense? So I'm going to rewrite this one more time. We're taking this first term and we're distributing it through. So I'm going to take x times x plus 5. And then I'm going to take the second term, which I'll highlight in a different color, and we're distributing that through as well. We're putting a plus sign because there's a plus sign here. And we're combining our like terms and then we're putting it in standard form. Does that make sense? So that's what we're going to do. X times x is x squared. X times 5 is 5x. Have a plus sign because of this plus sign. Then I have this addition sign. I'm going to drop down. And then I have a 2x plus 10. What like terms can I combine? 5x and 2x. And I end up with x squared plus 7x plus 10. Okay. Does that make sense? Try the next one, using distributive property. Alright, so I went ahead and distributed to find the product of these two binomials, and you should end up with x squared minus x minus 12. If you have trouble with what I'm doing right now, you really need to come in. You can always find me at lunch in room 603. I offer extra credits if you come in then, after school or before school as well. Those have to be scheduled on an individual basis, so just send me an email. But you do need to know how to do this. Okay, we're going to discover the shortcut before I just tell you what it is. So go ahead and copy that down. And I don't even really think of it as much of a shortcut. Alright, so before we would write it out like this. We would say, I'm going to take x times x minus 6. Then I'm going to put a minus sign, right? and then I'm going to put 3 times x minus 6. That was using the distributive property, right? We're going to be doing the same thing. We're just going to save ourselves that step. Right? So, I'm going to use different colors here, and I encourage you to do the same. What I do is I draw a bunch of little arcs here. I know I'm going to take this x and I'm going to multiply it by this x, right?
Yeah.
Those are called our first terms. They're the terms that appear first, right? You have x starting first here, x starting first here. So I'm going to represent that with an f. First. Okay, move on to the next. Okay, I'm going to take this x, and I know I'm also going to multiply it by that minus 6, right? Because that x has to be distributed to both terms. Yeah? So those are our outer terms. They're on the outer edge. So what I've done so far is I distributed my x to each of those terms. So x times x is x squared. X times minus 6 is minus 6x. All right. Now what other term do I have to distribute? The negative 3. So I'm going to distribute the negative 3 to that term. Those are the inner terms. You see that? They're inside. So when I do that, I have minus 3x. And then what's the last one?
Plus 18.
Yeah, plus 18. Last. These two are also negative 3 and negative 6. Those are the last terms. They appear second, right? So first, outer, inner, last. What does that spell? FOIL. Okay. So when I do that, I get plus 18. Now either way works. The way that I showed you before, if that makes more sense to you, and that is using the distributive property, then do that. If this acronym works and you just remember, oh, I have to take the first terms and multiply them, then the outer terms, and then the inner terms, and then the last terms, then do that. It's whatever works for you. I just know that a lot of teachers will say FOIL, and you need to recognize what that means when they say it. Okay, so you have x squared minus 9x plus 18. I don't even tell myself FOIL. I just say I need to distribute x to this x, x to this 6, 3 to this x, or 3 to the 6. That's all I tell myself. So that's what your book shows. So if you're going through your book, you'll see that that's what they did. The first terms, make that x squared, then the outer terms, inner, and the last terms. Any questions about that method of finding the product of binomials? Okay. Which one do you like better, that one or the one before? The one before? Both of them? Yeah, they're both good. But again, don't get lost in the sauce here. Like, don't think about FOIL and then forget what you're actually doing, which is distributing. So try again. All right, so again, I just think of distribution. I'm going to distribute this 2 to the 3 and this 2x to the 3x and that 2x to the minus 5. So I get 6x minus 10x. Perfect. And then I'm going to do the same thing. I'm going to distribute this 1 to the 3 and this 1 to the minus 5. And I get plus 3x minus 5. And then when I combine my own terms, I end up with, so I have, oopsie, I forgot a square, didn't I? There we go. 6x squared. So now I have 6x squared minus 4x minus 5. Great. 10, 9, 8, 7. 7x. Okay. Did you get that?
Yeah.
I'm making lots of little mistakes today. Okay. Good. Do you have any questions about that? Remember, FOIL can help you if you think about it first, outer, inner, last. So I just picked these two pictures because the way teachers teach this is silly sometimes. This one teacher was like, think about the claw. She made a claw. And another teacher was like, foil, obviously, which is the more popular one. And I remember being in college and my professor saying, well, it's kind of dumb that some high school teachers teach these things because, again, they teach them the kids, but then they have the kids think about a claw or foiling without really understanding what's happening. Yeah.
So for the last one, you're using about 6x squared is because there's 2 x's, like 2x,
Yes.
and then
Yeah, remember that. What happens when you take a 2x times a 3x? What are you doing to these x to the first?
okay, you're adding.
You're adding them. That's why we did the last chapter,
Okay.
right? Yeah. It's a great question. Okay. I found this. This is a pretty popular one. I foiled your plan. Yeah. Oh no, I see this every year. Okay, any questions about anything? Do you feel comfortable with this? Pretty easy to you? Good. Because they foiled the plan. First, outer, inner, left. Okay, well, show me how comfortable you are by getting all these correct. All right, once again, I encourage you to spend some time with these. Make sure you understand all of them. They're all good test questions, even the ones with the fraction. So, this is what you should have gotten. Are there any of those that you need to see? If you got the fraction one right, pat yourself on the back. Do any of you need to see number 7, 8, 6, 5? Yes. Yes, yes. 5? 7. Okay. 5 and 7. Five. M needs to be distributed to this M and that minus 7. So I have M squared minus 7M. Negative 3 needs to be distributed to this M and this minus 7. So I have minus 3M plus 21. So combining my terms, I have M squared minus 7, 8, 9, 10 M plus 21. Figure out what you did wrong? Okay, number 7. It's just a matter of remembering your fractions. And I don't know if I showed you this trick with fractions, but I'm ready to show you now. I learned it when I was studying for the ACT. Alright. I know I have to distribute the 2u to this u and this negative 3 halves. So 2u times u is what? 2u squared. Properties of exponents says that I add those. 2u times negative 3 halves is going to be minus what? Well, I'm just remember, if you have to write it out, then write it out. 2 times negative 3 halves. You're just multiplying across, right? So what do you get? 2 times negative 3 is negative 6 over 2, which is negative 3. So you have minus 3u. With me? Okay. Then I know I have a 1/2 u that I have to distribute. 1/2 times u is 1/2 u. So plus 1/2 u. And then 1/2 times minus 3 halves is minus what? Yeah, negative 3. So if we do 1/2 times negative 3 halves, what do we get? Negative 3 over 4. You with me so far? Yeah? So now I have to actually add which two terms? Yeah, the like terms, the minus 3u and the 1/2 u. So here's the trick with fractions. One way we said was finding a common denominator. We all learned that in elementary school, right? Here's another trick. If you're going quickly, and this is something when I wanted to move fast. So I have a 3u over 1, and I want to add a 1 over 2u. Okay. So here's what I do. I'm going to do this multiple times. Find the cross product. What's negative 3 times 2? Negative 6. What's 1 times 1? 1. I have to add those. And then I just multiply the bottom, which is what? 2. So negative 6 plus 1 is what? So I have negative 5u over 2. Does that make sense? So negative 5u over 2. That's the shortcut. Or again, you can multiply this by 2 over 2, and then you'll get the same negative 5u over 2. Just a trick. I learned that when I was your age. So you end up with 2u squared minus 5u over 2 minus 3 fourths. All right. You feel comfortable with all this? Okay. Do you want to keep moving on and have a break at the end, or have a break now? No? Okay, how many of you want to finish it? If you don't, I'm going to do it up here. So, we are taking a trinomial. Remember, we come up with trinomial, binomial, etc. based on the number of terms. So I have a 2-term thing in parentheses, a grouping, which is x plus 5. And then I have another grouping, 3 of those monomials, x squared, minus 3x, and minus 2, which make a trinomial. You cannot do FOIL here, so if you like FOIL, you can only do that with binomials. But we can use the distributive property again, which is what we've been doing, right? So that's literally what I'm going to do. The exact same thing. Take my x and distribute it to that x squared, that 3x, and I'm really short, but that minus 2 as well. And let me just read how those are. They're all right. Do this will work better. Okay, so yep. So distribute you get x cubed minus 6x squared. So you need to remember the cubes and squared. You're just doing your properties of exponents. Exponents multiplied together. You just add them. And then you have minus 2x. And then you do the same thing. You distribute. You distribute that 5 to the x squared, to the minus 3x, and to the minus 2x. So you have a plus 5x squared minus 15x minus 10. Yeah? And then you just combine all your like terms. So you start out with an x cubed. There's no other x cubed. That's gone. I like to cross them out. And then what else do you combine? Yep, which is a minus x squared. Cross those out. Yep, minus 17x. Cross those out. Minus 10. Yes. For,
Because you distributed x to 3x.
well, x to 3x. So x times a negative 3x. Oh, it's negative 3x here. Dang, why am I am ready for the weekend. I am. It's like 5 and 6 today. Thanks, Jane. Alright, so that's minus x squared, so we just have to change our middle. Well, I apologize in advance for all the people who are watching this video right now. Doing all the mistakes. Okay, so what will we have in the middle? Yeah. Plus 2x squared. Is that better? What do you think? Really, I would not pass this quiz. Okay. Any questions? I'm glad you're catching these mistakes though, because that just shows that you really know what you're doing. Okay. Alright, if you're watching this video, make sure you give these a try. Pause it here. And then you should get this. Did you get it? Did you not get it? Do you need to see any of those? 9 or 10? Which one?
Oh.
Both? Okay. Alright. Start with 9, and then we'll be done. Okay. X times x squared is x cubed. X times 5x is plus 5x squared. X times 8 is plus 8x. Yeah? Then, same thing for the 1. X squared, so I have a plus x squared plus 5x plus 8. Combine your like terms. X cubed, there's no other x cubed, and cross that out. I have an x squared, 5x squared, and an x squared, which make a 6x squared. Plus 13x. Plus 8. Yeah. Okay, so you see? I promised you a break, so, yes.
What was the answer to the second?
The answer to the second one just kidding, let me go. N cubed minus 5n squared plus 10n minus 12. Okay, your homework is to rewatch this video. Okay, I don't care when you watch it. I don't care if you are doing other things while you're watching it. As long as you watch it, make sure you understand everything very well and you can get faster at these. And accurate. Stay accurate.